What we have here, guys, is a light inextensible string is 1/8 meters long. One end is fixed to a point on a smooth horizontal table. The other end is attached to a particle of mass 7 kilograms. The particle moves in a circle on the table with a uniform angular speed of 4 radians per second. Calculate the tension in the string. Okie dokes. So, it's question 2, right? So what we have is, we're going to take the, almost like the helicopter view looking down. So does everybody understands that what I'm doing is that's a table, that's the circle, and the object is on the table circling around. Sort of like a hammer throw, okay? Except the hammer is staying on the plane of the table, okay? So what we have here is we have our center of the circle. So like in example 3, one end is fixed. So we're going to call this the fixed part. So the fixed part is the center of the circle, okay? So no bother there. And then the other end is attached to a particle of mass 7 kilograms. Now, which way you put it rotating doesn't matter, whether you go this way or that way. The same amount of force is required to keep it in position and keep it moving in a circle. Okay? So once again, I'll test your knowledge, okay? What direction is the linear velocity v going in? Linear velocity v, anybody? What direction does it go in? Tangent to the circle. Okay? If you're rotating this way, it goes up. If you're rotating this way, it goes down at a tangent. Everybody got that? Okay. Next thing. You have to identify which formula you're going to use. Is it F equals M, here it is here, mr omega squared? Or is it F equals mv squared over r? Which one is it? Keyword is, are you given angular speed or are you given linear speed? 4 rad per second. What type of speed is that? Angular. So choose this one to do your question, not the other one. Now, angular speed would mean that every second, let's say in 1 second, it moves from point B to point A. Yeah? Anti-clockwise. It covers an angle. This angle is measured in radians, so it's covered in 4 radians per second. So it covered 4 rad in 1 second, so that's 4 radians per second. Now, what's actually going on here? Okay, so what we're going to do is that our acceleration is directed in towards the center of the circle, so is our force. So to start off, centripetal force equals mr omega squared. Centripetal force, therefore, is equal to, anybody? Centripetal force? Sorry? Okay. So, centripetal force, the force needed to keep this moving in a circle is going to be 7 kilograms your right times 1/8 multiplied by 4 squared. Your centripetal force therefore equals 14 newtons. Everybody right with that? 14 newtons. Now, what's the one thing keeping this weight in position? They're linked together by a string, right? So therefore the string has a tension. The tension is the source of your centripetal acceleration, or sorry, is the force that causes it to move in a circle. The tension, no matter where the object is, if it's over here or all the way down here, the tension is always directed back into the source of the thing moving it around. Once again, if you ever throw a hammer in athletics, you'll feel that the tension is always pulling you out from the middle. Okay? So that's why the tension in this string is 14 newtons. Alright? Now, let's go on to question 4. A light inextensible string of length 5√2 meters is attached to one end to a fixed point P, which is 5 meters above a smooth horizontal table. So, what's happening is, I'll get my well, I get my parallelogram here. Be a good one to use. So parallelogram like so, and an ellipse, and now we have a pretty good looking diagram. Okay. Now, what I'm going to do is I'm going to go from the center to circle up, and I'm hovering here at 5 meters. Point P being 5 meters above the table. Okay. Now, what's happening is I'm going to do the next part in red. Okay. And what's happening is, oh, that's not red. Let's go again. Red. Okay. So what happens is I'm just going to draw these red lines to indicate that I'm swinging it around. And what it's doing is it's undergoing a circular motion while still being in contact with the table. Everybody alright with that? Sort of swing like that. Okay. Now that that's done, what we got to figure out is what are the forces at play here. Okay. So let's give it that 5 meters there. So this is 5. This is 5 root 2. Can I find out what angle A is by any chance? Angle A, anybody? Call it cos A. Cos A equals 5 adjacent divided by hypotenuse. Cos A therefore equals 1 over root 2. A equals 45 degrees. Everybody happy enough with that? Now, what type of triangle is this therefore? It's an isosceles. You could do Pythagoras' theorem if you want, but bottom line is that this other part here is going to be 5. So you could have just had, look, 5 root 2 squared equals r squared plus 5 squared. Bring it over and figure out what r is. It'll be 50 minus 25 equals r squared. R squared equals 25. R equals 5. Could have done that quite handy. Okay. Now that's done. Find the angle at which the string makes with the table is part 1. And we found that out to be 45 degrees. So answer to part 1 being 45 degrees. Okay. Now we want to find the tension in the string, right? Tension in the string. So there's 2 ways of doing this. In all these questions, there's 2 steps. F up equals F down. Why is forces up equals forces down? It's stuck in the table, which means it's not sinking into the table, nor is it being lifted above the table. So they're in balance in that direction. It's also undergoing centripetal acceleration, so it means choose either formula. Which one will I choose for this particular question? Constant angular speed. That means I'm going to choose omega over v. V is linear speed while omega is angular speed. Okay? Now, let's do forces up equals forces down. Okay, now, we got to resolve tension. What way is tension acting in this question? It's acting up that way, isn't it? Because it has to act up along the string. So we draw like a triangle for tension. Tension going up this way. This being A. So, or A also being known as 45. So, this is T sine 45, and this one is T cos 45. T over root 2, T over root 2, because it's going to be T multiplied by 1 over root 2. Because sine 45 is 1 over root 2, cos 45 is 1 over root 2. So it's going to be T over root 2 for both of them. Okay? So, T over root 2 for both of them. Now, what directions are they going in? Up and across. Now, it's only going right because on this side of the motion. When I'm over here, it's going to be going to the left, always towards the center of the circle. Okay, so let's start off with forces up equals forces down. What else is in play when you're in contact with a table? Everyone tell me? What else is in play when you're in contact with a table? Or any object? Think the wedges. The reaction force, or if you're supported by the table, you are going to be force acting straight up. Now, let me just specify something very clearly here. Remember on the wedges, R goes straight up, yeah? On a flat surface, R goes perpendicular to the surface it's on. If you're a flat surface, R goes straight up. If you're a circular surface, what way will R go? A circular surface. So an example would be the inside of a sphere, you know, like Evel Knievel style motorbiking around the inside of a sphere. What would that be? The R would go directly towards the centre of the circle. Okay, so just be aware that R is very dependent on the slope and the surface that object is placed on. Okay, so forces up equals forces down, guys. Let's start with forces up. What forces are going up? R is going up. Okay, what's going down? Or what else is going up? T over root 2 is also going up. What goes down? I haven't put it in yet. The weight being, how much kilos are we looking at here? 10 kilograms. 10g. So this is equation A. Equation A, no bother. Two variables. So we have two variables, so we can't really work that one out in isolation, okay? Let's go to equation B. Centripetal acceleration equals mr omega squared. Okay? Now, what is the force that's driving it towards the center? What's the force that drives it back in? What's keeping it in place? T over root 2. This tension here is keeping it in place. The force that's aimed towards the center of the circle of the motion is keeping that in place. Okay? I said like a hammer thrower, it's the tension or the strength of him keeping it in the motion going. Okay, so it's going to be T over root 2. It's perfect. M is 10. The radius is 5. And what's the constant angular speed? 1. Okay? So, looking for us, T over root 2 now equals 50 newtons. Or 50, just 50 newtons, but 50. Substitute that into the other one. Now, it's not 50g, it's 50. Okay, so you're not going to go negative either. So R equals R plus 50 equals 10g. R equals 10g minus 50. G is 9.8, remember? So it's going to be 98 minus 50. Your reaction force, therefore, is 48 newtons. Good with that? Okay, let's move on to the next one. Okay, a particle of mass m is moving with constant speed in a horizontal circle which is on the inside surface of a smooth sphere of radius 13 meters. A 13 meter sphere. Yes, that's interesting, right? So a massive sphere here. Not that massive, but big enough. Okay, we draw the center of the circle. Okay, now realistically, when you're moving around this circle, you're going to be in the bottom part. Okay, so you're here, and what you're undergoing is you're undergoing circular motion, like so, on the inside. Everybody picture that? Okay, so you're traveling around, and then on the way back, and the way back, and the way back, and then just constantly circling in there. Okay. Now, what do we know? We know that this point here to this point here is how much? Anybody? Give me a number. 13. We know that the center of the circle of motion 5 meters. So what do we know about this part here? The radius is 5. Then we can find out what x is, or h, whatever you want to call it. 13 squared equals x squared plus 5 squared. 144 equals x squared. X equals 12. Okay. Oh, below. The opposite way around, sorry about that. So what I got wrong there was that this is actually 5 meters below. And that makes sense because if I had it that long, we probably wouldn't be there. Or it'd be down here somewhere. And this here is 12. So I just got it the wrong way around. That's your radius, okay? Now, show that the speed. Now speed, which formula are we going to choose? Does it say angular speed? No, it says speed. So our centripetal formula has been chosen for us. There you go. And we also have to do force up equals force down. Okay, so force up equals force down, and then all the others. Okay, so first of all, let's start up with forces up versus forces down. What is acting directly down? Anybody? Directly down? mg, force of gravity, its weight. So mg acting directly down. What direction does the reaction force act? Does it act straight up, or where does it act? Towards the centre of the circle. Okay, so it's going to act up that direction there. Now, because it's acting up in that direction there, we need to resolve it. Because it specifically states forces up versus forces down. It doesn't say forces diagonal versus other diagonal. Okay, got to resolve that. So we're talking about what's it? Cos A being 12 over 13, and we're talking about sin A being equal to 5 over 13. So this being A, this being r cos A, this one being r sin A. Okay, so r cos A and r sin A. So r cos A is 12 over 13r, and r sin A being 5 over 13r. Okay guys, forces up versus forces down, let's go. What's going up? Now there's no string this time, isn't there not? No, it's just the object on its own, there's no string, so it's all reaction force. So what are we going to get? Sorry? Okay, so 5 over 13r, kill the bullet, equals mg. Good man. Okay, next one. Fc equals mv squared over r. Now what we taught about the velocity? 16 point. Oh, sorry. Show that the speed is 16.8. So we have to find out what v is. Okay. What's Fc? What is going towards the center of the circle? What is driving this back in to make it circular motion? What force is making that happen? 12 over 13r. Good man. Its mass being m. Its velocity being v squared at the moment. Its radius being 12. Now, suppose the way to do this would be isolate r. I'm going to go back up to the first equation. R equals 13 mg all over 5. Replace it in for r. 12 over 13 multiplied by 13 mg all over 5 equals mv squared all over 12. Now let's cross out the 13 and the 13 cancel. The m and the other m cancel. So what I'm going to be left with is 144g over 5 equals v squared. So can somebody multiply 144 by 9.8 and then divide it by 5, square root the answer. So guys, so somebody found that out to be v equals 16.8 ms to the minus 1. Done that question, we're in business, let's move on. Okay. Question 6. A conical pendulum consists of a particle of mass m at the end of a piece of string, 1 meter long. The other end is fixed to a point on a ceiling. The particle is made to rotate in a horizontal circle, so the string makes an angle of 30 degrees with the vertical at all times. Find the tension in the string in terms of m and g. Find the constant angular speed, omega, correct to 3 decimal places. Okay, so let's draw a 30-degree angle. So 30-degree angle there, and then let's draw my ellipse. I'll make that just a bit bigger. So you can see that it's going around in a circle, so it's traveling along this way here, all the way around. Okay. You guys should more or less be able to tell me what to do now at this stage. Okay, so what's our two formulas? What'd you say? F up equals F down. Okay. What forces are going up or down? Tension, yeah. 30 degrees. T cos 30. T sine 30. What's cos 30 is root 3 over 2, isn't it? So it's going to be root 3 over 2t. And the other one's going to be a half t. T over 2. And that's going into the left, and that's going up. Okay, so forces up equals forces down, guys. Let's go. What's up and what's down? So up is down G. Isolate T. T is going to equal 2mg all over root 3. You'll see that was quite obvious to isolate T in 1 second. Okay, what about the centripetal acceleration? What formula am I going to use? Omega squared, yeah. And so what's our force going back in towards the centre? What do we replace this with? T over 2. Mass m. R is, have we worked out R yet? Okay, so we have no idea what R is just yet. So MWT equals NWR. So there's got to be information here somewhere. The string's 1 meter long. So 1 meter long, yeah? And that's going to be 1 sine 30. And sine 30 is going to be? Sine 30 is a half, isn't it? So it means it's a half a meter. The radius is a half a meter. So m times 0.5 multiplied by omega squared, which is, we haven't got a clue what that is yet. So answer the tension in terms of m and g, and then what we're going to do is replace t there. So it's going to be 2mg all over root 3 all over 2 equals m times 0.5 times omega squared. The m's will cancel. The 2's will cancel. I'm going to be left with g over root 3 equals 0.5 omega squared divided by a half. So what's g over root 3? So 9.8. Okay. 9.8 divided by root 3 divided by root 3. Now once I divide that by root 3, I then need to divide it by 0.5. That's what omega squared is equal to. Then I'm going to square root that. 3.36. 3.364. Okay, what's the units? So rad s2 minus 1 or rad slash s. Okay.